Hello everyone. Today we'll continue with our studies on the quadratic equations. Today we'll look at three other notions. The first one being the equality of quadratic equations. What do we mean to say that two quadratic equations are equal? Alright? So equality of quadratic equations. Now, if we are given a quadratic equation, ax squared plus bx plus c, and we are told that it's equal to another quadratic equation, px squared plus qx plus r, then this equality is only possible if coefficients of corresponding terms are equal. All right? Okay? So ax squared plus bx squared plus c is equal to px squared plus qx plus r if and only if, all right, coefficient of corresponding terms are equal. Okay, a is equal to p for the x squared terms, and b is equal to q for the x term, and c is equal to r for the constant. So x squared term, x term, and then the constant. This is a condition for this quadratic equation to be equal to that quadratic equation. Now, this will help us solve our first question here. We are given the quadratic expression x squared minus 4x plus minus 1 to be identically equal to x plus b, all of that squared plus c, and we are asked to find the value of b and c. All right? If x squared minus 4x minus 1 is equal to x plus b all squared plus c. Alright? If this quadratic is equal to this quadratic, then coefficient of corresponding terms must also be equal. Alright? Now, this one is already well expressed. Let us open up this bracket and put it in the real quadratic form. Alright? X plus b all squared means x plus b, x plus b plus c. Now this gives us x multiplied to x, x squared, x multiplied to b, xb, b multiplied to x, bx, b multiplied to b, b squared plus c. This gives us x squared, xb, bx, they are the same thing. Whether x is at the end or at the beginning, they are the same thing. So we just have what? 2xb then plus b squared plus c. So we are saying x squared minus 4x minus 1 is equal to x squared plus 2xb plus bx plus c. Now let us arrange this to follow this arrangement here. So we have x squared plus 2bx. All right. The coefficient of x here is 2b, and then plus our constant b squared plus c is equal to x squared minus 4x minus 1. Alright, this quadratic expression equals to this quadratic expression. That can only be true if and only if, alright, coefficient of x squared term. So let's start with x squared term. Coefficient of x squared term are equal. The coefficient here is 1 if and only if 1 is equal to 1. So there we have perfect equality, no worries. Now, we take next the x term. Alright, the x term on the left hand side, the coefficient is negative 4. We expect that to be equal to the coefficient of the x term on the right hand side. Now, this gives us an equation in terms of b, from where we can calculate b if we divide both sides by 2. 2 cancels, 2 here 1, 2 there, negative 2. So finally we have b to be negative 2. Alright, we have the value of b. Now if we take the constants, the left hand side is negative 1 is equal to the right hand side, which is b squared plus c. Alright, so we have negative 1. We know the value of b. The value of b is negative 2. So negative 2 squared plus c. So we have negative 1 is equal to negative 2 squared is 4 plus c. Alright, so if we take this positive 4 to the left hand side, it becomes negative 4. So we have negative 1 minus 4 is equal to c. And so our C is -5. Alright? So this gives the solution of the value of B and C in our first equation. To be able to solve the second equation, we need to take the next notion about quadratic equations. The next notion about quadratic equations will be the notion of the relationship between the coefficients and the roots of any given quadratic equation. So the next notion is relationship between the coefficients and roots of a quadratic equation. Between the coefficient and roots of a quadratic equation. Given any quadratic equation ax squared plus bx plus c equals 0 with roots, say alpha and beta, then sum of roots, that means when we add them up, is given by -b all over a, and the product of roots, that means we'll multiply the two roots together, is given by c all over a. Okay, so these are the relations between the coefficients of a quadratic equation and the roots of the quadratic equation. Alright, so this material will help us to solve our second question. Our second question goes thus: if alpha and beta are the roots of the quadratic equation of the roots of a given quadratic equation, then with the sum of roots being 2 and product of the roots being half, we are asked to find the value of alpha squared plus beta squared. How do we get to that? Alright, so question 2, we know that alpha plus beta all squared is equal to alpha squared plus 2 alpha beta plus beta squared. Okay? But we are asked to find an expression made up of alpha squared plus beta squared. Alright? So alpha squared plus beta squared, and we take just this and this. Alright? Is gotten when we take plus 2 alpha beta to the left hand side. Alright? So this one is already on the left hand side. So we have alpha plus beta all squared is already on the left hand side. Plus 2 alpha beta coming this way will be minus 2 alpha beta. Will give us alpha squared plus beta squared. So to evaluate alpha squared plus beta squared, we have to evaluate this left hand side. This left hand side is good because here we already have alpha plus beta, which is the sum, and we'll have alpha beta, which is the product. Okay? Alright. Now, we were given in the question, we're given alpha plus beta to be 2, and we're given alpha beta to be a half. So from here, alpha squared plus beta squared will be alpha plus beta squared. I'm rewriting this minus 2 alpha beta. Okay, that will be alpha plus beta is 2 squared minus 2 alpha beta. This gives us 4 minus 1, which is 3. Alright? So that solves our second question. The value for alpha squared plus beta squared when we know the sum and when we know the product. Okay? Alright. Now we go to the last notion for the day that will enable us or will help us solve the third question. The last notion of the day brings in something new in addition to the relationship between the coefficients and the root of a quadratic equation. Okay, so this one stays the coefficient and the roots of the quadratic equation. Okay, if given the quadratic equation ax squared plus bx plus c equals 0 with roots alpha and beta. So we know that the sum, okay, the sum is minus b all over a and the product is c all over a. Okay, now if given new roots, write it like that. All right, to find new equation. So what we have to do is we have the sum of new roots, we'll get it, and then we'll also find the product of new roots, so that the new equation has the nature x squared minus sum of new roots multiplied to x plus product of new roots equals 0. Right? Let's write it very well so that it will be clear for everyone to see. So new equation will be x squared minus sum of new roots multiplied to x plus product of new roots equals 0. This is the nature of the quadratic equation. Okay, let's attempt now solving the third question. Given that the roots of the quadratic equation x squared minus x plus 2 is equal to 0 are alpha and beta, find the quadratic equation whose roots are 1 all over 1 plus alpha squared and 1 all over 1 plus beta squared. Okay, so uh, we have roots alpha beta. So we start with the sum of roots. So we have sum of roots now. So let's just use what we have here. So let's use what we have here. Our equation is x squared minus x plus 2. Alright? So have x squared minus x plus 2 is equal to 0. X squared minus x plus 2 is equal to 0. Now, sum of root alpha plus beta is minus b all over a. That should give us, now here our a is 1, our b is -1, and our c is 2. So this will give us minus 1 all over 1, which is 1. And then this one will give us alpha beta is c all over a. Our c is 2 all over 1, which is 2. So we have the two values. Okay, we have the two values for the sum and the product. Now, new roots. New roots are given as 1 all over 1 plus alpha squared and 1 all over 1 plus beta squared. So, sum of new roots will be equal to 1 all over 1 plus alpha squared plus 1 all over 1 plus beta squared. Okay? This will be equal to the LCM is just their product. 1 plus alpha squared multiplied to 1 plus beta squared. Okay? This product divided by 1 plus alpha squared, 1 plus alpha squared cancels 1 plus alpha squared, we are left with 1 plus beta squared. Multiplied to 1 plus beta squared. Plus this product divided by that 1 plus beta squared cancels 1 plus beta squared, we are left with 1 plus alpha squared. Multiplied to 1 plus alpha squared. So this gives us alpha squared plus beta squared plus 2 all over, we multiply out this, 1 multiplied to 1 is 1, 1 multiplied to beta squared, alpha squared multiplied to 1, alpha squared multiplied to beta squared is alpha, beta, all of that squared. Okay, alpha squared beta squared is the same as alpha beta all of that squared. Alright, so this gives us alpha squared plus beta squared, as we saw earlier on, is simply alpha plus beta all squared minus 2 alpha beta plus 2. Okay, all of that divided by 1. Here again we have alpha squared plus beta squared, so we have alpha plus beta all squared minus 2 alpha beta plus alpha beta all squared. Okay, so we have succeeded to express the sum of new roots in terms of alpha plus beta and alpha beta, so that we just come in and put our respective values. All right, so alpha plus beta is 1, so we have 1 squared is 1, so we just have 1. All right, minus 2 alpha beta. Alpha beta is 2, so we have 2 multiplied to 2 plus 2, all of that divided by 1 plus alpha plus beta. Alpha plus beta is 1, so we have 1 squared, which is the same as 1, minus 2 alpha beta. Alpha beta is 2, 2 multiplied to 2, okay, plus alpha beta squared, which is 2 squared. Okay, so this gives us 1 minus 4 plus 2. 1 minus 4 plus 2 all over 1 plus 1, which is 2, minus 4 plus 4, which is simply 1 minus 4 is negative 3 plus 2 is negative 1 all over 2. So sum of new roots gives us negative half. Sum of new roots gives us negative half. Okay, so let's write it somewhere here. Sum of new roots is negative half. Now we want to look for product of new roots. Okay, now let's take off this. Let's take off this. So we can now evaluate the product of new roots. Product of new roots. That means 1 all over 1 plus alpha squared multiplied to 1 all over 1 plus beta squared. Now this gives us, since nothing can cancel, 1 multiplied to 1, 1, all over, we multiply out the denominator, 1 multiplied to 1 is 1, plus 1 times beta squared, plus alpha squared, plus alpha beta all squared. Okay, this gives us 1 all over 1 plus alpha plus beta squared is alpha plus beta all squared, alright, minus 2 alpha beta plus alpha beta all squared. Alright, so we have also expressed this in terms of sum and product. So when we have sum, we will now write negative 1, and we'll have product, we'll write 2. So we have 1 all over 1 plus negative 1 squared. 1 all over 1 plus 1 squared. The sum is 1. Okay, sum is 1 squared minus 2, product is 2, 2 multiplied to 2 plus 2 squared. Okay, this gives us 1 all over 1 plus 1, alright, minus 4 plus 4. Alright, that simply gives us 1 all over negative 1 plus 4 is 0, 1 all over 2. Okay, so product of new roots is a half. Okay, now that we know the sum of new root and product of new roots, now let us form our equation. Okay, forming our equation, we come and put it in this expression here. So we say new equation, new quadratic equation, all right, will just be new quadratic equation. We'll write this out, will be x squared minus sum of new roots negative half multiplied to x plus product of new roots a half equals 0. Okay, now if we multiply all through by 2, we're going to have 2x squared minus minus gives us plus x plus 1 equals 0. So this is the quadratic equation whose roots are 1 all over 1 plus alpha squared and 1 all over 1 plus beta squared. When we know that the roots of x squared minus x plus 2 equals 0 are alpha and beta.